Fast radio bursts, those mysterious, ultra-powerful flashes of energy from deep space, are among the most baffling phenomena in modern astronomy. These signals last only milliseconds, yet they carry energies equivalent to what our sun produces over several days. For years, scientists have been chasing these cosmic whispers, trying to decode where they come from and what causes them. But here's where it gets controversial. Despite decades of research, we still don't fully understand their origins, and some theories challenge long-held assumptions about extreme stellar behavior. Recently, a team led from Northwestern University made headlines by not just detecting one of the brightest FRBs ever recorded, but also tracing its source with remarkable accuracy. The signal, named RBFLOAT, was first picked up in March 2025. It lasted mere milliseconds, but packed an enormous punch, releasing as much energy as our sun does in 4 full days. Using a new analytical technique, researchers were able to trace its origin back to a spiral galaxy located 130 million light-years away, specifically within a star-forming arm in the direction of the constellation Ursa Major. Their findings were published in the astrophysical journal Letters. The detection was made possible through a collaboration between Canada's CHIME radio telescope, one of the world's top FRB hunting instruments, and a network of smaller ground-based stations known as outriggers. While CHIME captured the initial burst, the outriggers helped triangulate its location down to a narrow patch of space. Follow-up observations using optical and X-ray telescopes provided additional clues that helped pinpoint the exact region within the galaxy NGC 4141. The precision achieved? Just 13 parsecs, or about 42 light-years, which is impressively accurate for such a distant event. What makes RBFLOAT even more significant is that it came from a non-repeating source. In previous cases, scientists had localized FRBs that repeated multiple times, making them easier to study. But this one-off signal posed a much greater challenge. RBFLOAT was the first non-repeating source localized to such precision, said Sunil Simha, co-author of the study. These are much harder to locate. Thus, even detecting RBFLOAT is proof of concept that CHIME is indeed capable of detecting such events and building a statistically interesting sample of FRBs. So, what could have caused RBFLOAT? Scientists are still debating the answer. Because of the immense energy involved and the incredibly short duration of the burst, experts believe these signals likely originate from extremely violent cosmic events. Possible culprits include neutron star mergers, pulsars, or magnetars, highly magnetized neutron stars with magnetic fields billions of times stronger than Earth's. In the case of RBFLOAT, the data suggest it originated in a region of active star formation, filled with massive young stars. This supports the theory that the signal came from a magnetar. And this is the part most people miss. Magnetars are not just any neutron stars. They're among the most extreme objects in the universe, capable of unleashing tremendous amounts of energy in a fraction of a second. This breakthrough opens the door for future discoveries. The same triangulation method used to track RBFLOAT can now be applied to other incoming signals. According to the research team, CHIME alone could potentially detect around 200 accurately localized FRBs per year. For years, we've known FRBs occur all over the sky, but pinning them down has been painstakingly slow, said Yuxin Dong, another member of the team. Now we can routinely tie them to specific galaxies, even down to neighborhoods within those galaxies. But here's the twist. While many scientists lean toward magnetars as the source of FRBs, others argue that alternative explanations, like exotic physics or even artificial signals, shouldn't be ruled out entirely. Could some FRBs be something we haven't imagined yet? Or are we simply witnessing the extreme limits of known astrophysical processes? What do you think? Should we keep our minds open to unconventional theories, or is it time to double down on magnetars as the definitive answer? Share your thoughts below, and let's get this conversation started.